what's going to happen is that our brain is going to use it as a way of creating feedback and learning, and make people be able to take control of it in their hands more often.
All right, well, this is a new topic on the podcast. Whether you're into technology or not, it's a fascinating look at the future, where we're headed, and what's possible. Today I'm speaking with Dr. Ramses Alcaide, who's an electrical engineer, neuroscientist, and CEO of Neurable, an innovative brain-computer interface company. At Neurable, he's the inventor and primary developer of a brain-computer interface technology that's designed to turn human biometrics into actionable insights. Dr. Alcaide is also a two-time winner of the Neuroscience Innovator Award and recipient of the National Science Foundation Fellowship and Ford Foundation Fellowship, and he's been named to the Forbes 30 Under 30 list. Dr. Alcaide has a degree in electrical engineering from the University of Washington and a PhD in neuroscience from University of Michigan. So without further ado, here he is.
All right, I'm here with Ramses Alcaide. Ramses, welcome to the FitMind podcast.
Hey, how's it going, Liam? Great to be here. Really excited to talk about the future of wearables.
Yeah, awesome. I mean, this is a subject that we really haven't talked much about on the podcast. We did have a session on the Muse brain sensing headband for meditators, but it's a fascinating world, and it seems like it's come a long way. So how did you first get into this world of brain-computer interfaces?
Yeah, absolutely. So really my story begins when I was about 8 years old. My uncle got into a trucking accident and he lost both his legs. And it was one of the most traumatic moments for me in my life, but it really made me motivated toward how do we create technology that helps people participate equally in the world. And so I went to the University of Washington. I studied electrical engineering there, primarily for prosthetic control systems, so controlling, limbs for people who have amputations. And that's kind of when I realized that there's this huge disconnect between the actual brain and machine interface. So I did my master's at the University of Michigan and eventually my PhD. And we created a new technology for interpreting brain data that let us do it hundreds of times better than existing systems. And that's really where at least my career at Neurable started out. Spun out the company from the university and started building what we call, the next generation of brain-computer interfaces.
Awesome. Yeah. And before we get into that specific technology, I think it'd probably help to give listeners just a primer on BCIs. What are they generally used for at this time? And what are we really talking about here? What's the high level overview on BCIs?
Yeah. What I would say is there's kind of three types of brain-computer interfaces out there. The first type is non-invasive, so it means it requires no surgery. And that's the type of work that we do, which is, you put on what are called hearables, which is something that you put around your ear or head or et cetera. It can be, at least in our case, a pair of headphones or earbuds. But for others, it could be like a giant mesh net on your head. And then that records electrical activity from your brain. And you can use it to either better understand yourself, like your own cognitive health, understand biomarkers of different disease states, or use it to control devices. And the positives there is that it doesn't require surgery. They can be something that can be used for consumers, but at the same time, the accuracy and the types of applications that you can use are very limited. Then you have invasive systems, and that's groups like Neuralink, for example, and that requires surgery. And those are more of if a non-surgical system is like buying a pair of shoes, something that's useful but everyone uses. Neuralink is similar, akin to like a prosthetic leg. You wouldn't get it because there's a risk to your life getting these surgical devices implanted, unless you had something significant like you were quadriplegic or you wanted to, communicate with somebody and you were locked in. And then the third set, which is also kind of where we fit in as well too, is what I would call is the next mentality of what a brain-computer interface is, which is some individuals use other things that aren't brain signals directly in order to understand human intent. So they use, for example, muscle signals to understand how a person wants to move their arm, or they use accelerometers to predict, how to make a prosthetic leg land in the right place, right? And so the real concept of a brain-computer interface means that you're using your brain to interface with a computer. And whether that intent is coming from your brain directly or from secondary systems, that third group of BCIs is kind of expands the scope of what we consider human intention and where we get it from.
Yeah, and how does that take place? I mean, I know this is vastly more complicated than we could cover here, but just at again, kind of just an overview level, how could one's brain interface with a machine at this point?
Yeah, definitely. I'll kind of cover it just from the non-invasive perspective, but it's very similar across all of them. So, your brain, as you do different actions or as you want to do an action, fires neurons, and these neurons create electrical activity. That electrical activity sometimes is large enough that you can actually record it from outside the head, right, on the scalp, essentially. And the sensors that record that scalp data, they're called EEG sensors, or electroencephalography. That data gets sent to a small computer, and on our end, what we do is we process that signal and boost what the brain output is within that signal to make it usable. And then from there, developers can do anything. They can use it to help control a prosthetic limb, or turn on your music or turn off your music, or the lights and the environment around you. Or they can also use it to better understand yourself. So are you feeling tired right now? Are you burnt out? Are you focused, etc.? But essentially all of that comes from large neuronal firings picked up by a sensor and then interpreted by a computer.
And so presumably you collect enough data that you understand these neural correlates, this brain activity is associated with, say, focused or unfocused. Is that right? And then that's how the machine has learned how to recognize those states?
Exactly. That's one application of it. Yes.
Mm-hmm. And then, I was reading that this BCIs really weren't all that useful until the relatively recent future. I mean, with some exceptions and, for example, prosthetics that you mentioned and such, but it seems like there's really, could you walk us through a little bit of the recent advances that have made BCIs more useful?
Yeah, definitely. What I would say is, the first time that we saw electroencephalography, or EEG, being used for something that's an application instead of just monitoring the brain was in the 80s. It was by Immanuel Donchkin, and he used it to help an individual type using his brain. And it was non-invasive, and it was a really incredible application. But, the road toward taking that technology from those large laboratory settings to an actual everyday device that can create usefulness has just begun, really. For the majority of the time, if you needed to use these systems, it'd be these large, bulky systems with gel. In the I would say probably the late 90s, we finally started seeing the first dry electrode or dry sensor technology. So they didn't require gel. And that was a huge evolutionary step. And then getting those sensors to be good enough to record data that competes with these gel-based sensors was also a big technological step. And then about 10 years ago, where we started this technology at the University of Michigan, came kind of the next giant evolution. And what that was is just like voice about 10 years ago changed in its application because of machine learning, so did analyzing brain data. And that's why we see voice everywhere. There's a huge revolution in how voice was being processed. And we essentially did the same thing with brain data. And so now you're starting to see everyday brain-computer interfaces becoming a real possibility, because you have all these technological aspects of hardware changes, removal of gel, miniaturization of electronics, and then now finally the big missing piece is like, how do we make signal from these everyday devices useful? And that's really what we focus on as a company.
So back in 2017, you created the first mind-controlled virtual reality game. Is that right?
Yeah, that was pretty awesome. Essentially, it was escape the room, but you used only your brain to use telekinetic powers, essentially, to go through and escape the room. You could grab objects, throw them, type on keypads. It was really an incredible experience.
Yeah, so you've talked about how thought-controlled interfaces are going to make VR ubiquitous. how can a thought be put into language that a machine can understand? It just seems to me like a thought is so intangible. But is it an intention that's being measured there, or what's being read exactly?
Yeah, that's a great question. And I guess the way that I would put it is thoughts are intangible, like to a certain degree, at least for non-invasive or non-surgical systems. And so it's not so much about, understanding what a person's thought is and then turning that into control. It's more high level. For example, let's say that you wanted to click through a slide deck. And I do this right now whenever I talk to venture capitalists or do presentations. I'll be wearing my headphones and I'll actually be clicking the slides using my headphones, right? Hands-free, voice-free. It's super cool. Or if I'm on Zoom calls, sometimes I'll put them on and I'll have a control mute and unmute. So it's not like I have to think mute or unmute. There's a very simple command that I do, just like you do with your mouse. You click or you don't click, right? That enables me to activate a specific action. And so thought control is not something that we're going to get to realistically, non-invasively, but we don't have to get to that level of information in your brain in order to make a useful brain-computer interface. And that's really, the key advantages that we have with the non-invasive approach, which is customers don't need to, control, a prosthetic limb for the most part, right? Customers don't need to have like a doc-ock device where, they have all these extra hands. And, that's not a necessary thing. We have robotics to do that. We have your own arms and legs. But how do you make controlling your technology easier? How do we create the computer mouse for augmented reality or virtual reality? Those are problems that are well within the grasp of non-invasive systems and provide a really strong solution for them.
Yeah, and so I was reading that one of your breakthroughs at Neurable is that unlike some of the other BCIs, like say a Muse headband, you're using something called event-related potentials. Do you think you could explain what that means?
Yeah, absolutely. And so this is more back when we were in 2017, when we did that kind of work. What our platform allows us to do is take any brain signal and amplify the most important aspects of it. And so when we did that virtual reality demo, we looked at something called the event-related potential as a control modality for the game. And the way that it works is it's actually a very old part of your brain. And what happens is whenever you're processing information and you see something that's important to you, and that important thing changes in some way, like let's say you're going down a grocery aisle and you're looking for Fruit Loops, right? And you're looking at all these cereal boxes go by you. And in the corner of your eye, when you see that Fruit Loops box, your brain goes, oh, there it is. That's the important one.
Is that the reticular activating system?
It's connected to that, but it's actually just a part of your brain that when it notices something important change, activates, right? And so essentially we use that modality as a form of control. It's called the event-related potential. And you can use it to control different environments. For example, let's say you're in a virtual reality environment. I can put different objects in front of you, and then I can make the objects change in the way, either by highlighting them or by moving them a little bit. When your brain sees something that you want to move or change, it says, oh, that's the one that I care about. And then and when we pick up that, oh, that's the one that I care about signal, we know to grab the object and give it to you. And then we can use that to essentially help you control an entire game.
Wow. I mean, that's really futuristic stuff. It's incredible. So, all right. So that was your earlier project. And now you're working on Enten, or you've come out with Enten, these EEG headphones. Do you think you could explain a bit more about how those work and what the application is?
Absolutely. So with this latest system that we've brought out, and once again, our main core is the software behind it. We actually build a lot of this hardware devices with partners. So what we've done is our quest has been, how do we make these every day? So in the past, it was these gel cap systems, and our goal was, how do we make them into something that can fit into a consumer product? And in 2017, the closest form factor that we could achieve a usable prototype with was a virtual reality system, because you can have large sensors in the back of the VR system and they look normal enough, right? It's not weird. But then we wanted to, as we continued improving the system, we wanted to get even smaller. What if we could make a pair of headphones or earbuds that you could use to control your devices with? And so we started exploring with ear-based systems. And after a significant amount of work, we were able to improve our signal processing and machine learning to the point that essentially that game that we used to play in virtual reality in 2017, we can now just play with a pair of headphones. And instead of, using the headphones for, clicking on things, we can also use them to understand an individual's cognitive state, or use it to help them, for example, when I'm on calls, mute or unmute automatically my Zoom, or help me move through slides without having to click it, which leaves my hands free to, show things or to do other things with them.
Wow. And so, what's the main use case right now? Because someone might say, I mean, it's really cool, but someone might say, I'm fine changing slides with my mouse or my keyboard. So what's really the use case here?
Yeah, you bring up a really great point, which is, and we found this very early during our customer discovery as well too, which is people don't need a new way to click for the most part. Like, they don't need a way to click through slides. So we did a lot of customer discovery to understand like what would provide great value for a person. And what we found is that people are working from home more and more, and they're actually getting burnt out more often. They're having trouble concentrating more often. And so what if we could use our brain-computer interface to better help them overcome that challenge? And so our current system, and along with slide clicking and all the other stuff that it can do, when you put on the system, it can actually detect whether you're trying to get into focus or not. And if you are, it'll start playing music that helps you get into focus more easily. Then once we detect that you've entered focus, we'll automatically turn your computer into do not disturb mode, so you don't get notifications popping in. We'll automatically put noise cancellation on, so you're essentially in this like cocoon of focus. And then instead of notifications bothering you, what we can do is we can actually play a music tone when you're becoming distracted, so that you get a little bit distracted, but it's because you're about to get very distracted. And so you're able to bump back into your original task faster. And so we're essentially able to keep you in that area, that flow state for longer. And then when you're starting to fatigue, we know when it's the right time for you to take a break. So you can actually come back with refreshed ideas, feeling motivated and accomplished. And so we'll tell you, hey, go take a break, go take a 5-minute break, go for a walk. And what you'll actually end up seeing is that people are able to nearly double their productivity per hour while still feeling refreshed. And that's really what we're all trying to accomplish. And what I learned is that there's 2 ways to end your day. You can either work 10 hours and be like, man, I did so much, I feel so motivated, like I really crushed it today, I love my job. Or the opposite, which is like, man, I worked 10 hours, I feel like I got nothing done, and I really hate what I'm doing. And the difference there is are we able to give people the ability to really focus on what they're working on instead of bombing them with distractions? Are we able to give them breaks at the right time? And so this tool really empowers people to find that balance and to end their day feeling accomplished, getting more done, and then being able to spend more time with their family because they've been able to knock out more work in less time.
Yeah, that's a great point that you bring up about there's different, 10 hours of work does not mean 10 hours of productive work or 10 hours of effective work. Your decision making could be awful if you're full of distraction and constantly diverting your attention in different ways. And so it seems like that's a really good use case, and both as like a flow activator with the music, but then also some kind of mindfulness alarm, almost detecting that distraction in a way that is really tough to do in our computer environment, where there's just notifications zinging in from all sides and there's an internet sinkhole waiting to be dropped into at any moment. So I can see how useful that would be.
What I think is really relevant to that too is Microsoft did a study where they had people go through a normal meeting and a Zoom meeting, and it turned out that Zoom meetings were like twice as exhausting as normal meetings, which I get. It's like staring into a screen. versus being actively and dynamic with a person, technically you're accomplishing the same thing, but the medium is far more exhausting, right?
Right.
And so not only are our tools more exhausting now that we have this hybrid work situation, but then, like you're saying, there's distractors everywhere. There's excuses not to go do things. And what if you had a tool that could empower you to put that under your control, right? And so, and we found that that is truly useful to people. And so while we can give them the ability to click through slides, change their volume, do things like that, that's just more convenience. But the other one is a true pain point being solved. And that's really what the team is making sure is flawless for our customers.
It's cool. Yeah. I mean, I think we're still pretty new to a lot of these tools and figuring out how to use them effectively as tools and not let them use us and drag our minds around. So it's interesting using technology in some ways to combat technology or the negative potentials there for for low quality work, and really make sure that the tools remain effective. And it's definitely true about feeling more exhausted working on or interfacing on the computer. I think one potential reason too is this idea of email apnea, where people seem to stop actually breathing in a calm way. They kind of hold their breath for a little bit longer, almost in anticipation of the next trigger or stimulus that might come their way.
Yeah, I mean, there's a lot of those kinds of situations, even just like getting vibrations continuously of notifications. Like that is incredibly stressful for a person, right? Like the way that our entire digital world is connected, the fact that you're available all the time, all of these things are not normal for who we are as people, right? Like human bodies and brains weren't meant to be always on like that. And it's the fact that we have that level of availability drains us, makes us feel fatigued, makes us feel burnt out. And really learning how to take control of that is such a key step. And it's not about like maximizing a person's productivity as much as it is like, empowering people to take control of their technology.
Now, just to play devil's advocate, what you've created with Enten wouldn't fall into this category, but I think the concern that people might have with BCIs is manifold, but just this idea of kind of losing our humanity by becoming too cyborgish, or there's the safety and hackability concerns. What if someone could control your mind, could actually hack into some chip or something that's a part of you, and then there's the unfair advantages that someone might gain if they were just wealthy enough to afford these cognitive enhancers. So have you thought at all about how you're addressing some of these concerns around BCIs?
Yeah, absolutely. It's actually, ethics is something we really care about here. We've done a significant amount of blog posts about our stances on ethics. The 5 like neurocognitive stances that we have as well too, which include accessibility as a holistic word, which is making it affordable, making sure that people have the ability to take it off, right? If you have something implanted in you, it means you can't take it out unless you get another surgery, right? But with headphones, earbuds, AR glasses, you can just take them off, right? And so there's a lot of these kind of concepts that you need to think about. On top of that, there's like, who has the power, right? If you make it as something that is targeted for a company, for example, imagine a call center company. If it was to the benefit of the company, the way that it would work is that they would want to monitor their employees, and then they would want to know like who's working versus who's not, right? But we actually found that's actually detrimental, right? And also not core to our values as well. The best thing to do is to, give this technology to people who are working at this, customer support center, et cetera, in order for them to manage, their breaks, in order for them to be empowered by the technology. They'll make the right decisions for themselves, because if there's something that we've learned, and this actually comes from a mentor of mine, his name is Richard Sheridan, who wrote the book Joy Inc. It is human nature to enjoy your work, right? To enjoy work. You need to do something, right? But there is so many ways that we can sap that enjoyment out of people, right? And so how do we make people enjoy those hours that we're paying them for so that they feel motivated to be their best selves. And people want to be their best selves. Like nobody wants to go to work and just like feel like crap for 8 hours, right? That's not something that people want. And so we make technology for the people who are working, not technology for the companies to be like monitoring you, right? And part of that is making sure that the sales structure is set up that way, right? We don't share your data, and you should demand that kind of work from future BCI companies as well too. How do we make sure that we have the opportunity to put guidelines now that especially we've learned from the mistakes of the internet age and all this like privatization issues that's happened. Like, let's not repeat those mistakes. Let's make sure that we focus on companies and demand from companies that do neurotech to follow these types of guidelines.
Do you think you could paint a picture of us for what the future might look like with BCIs? Maybe your vision or just where you think the industry's headed?
Yeah, absolutely. I'll just kind of share some of the high level, which is I see an evolution happening right now in hearable technology. What I mean by hearable, I mean headphones, earbuds, eventually AR glasses, etc. Right now, especially headphones and headphones and earbuds, they're used as devices for listening to music, right? The next step, they're going to be used as devices that have sensors for wellness, right? They're going to have accelerometers to track your steps. They're going to have EEG sensors that go in the ear or around the ear in order to help you maintain focus. And you're already starting to see this in software. Look at Apple's latest software updates. It's all about helping people maintain focus, put do not disturb on, etc. Now we're going to be able to make that a seamless experience for people. Then the next step after that is going to be control. Imagine putting on an AirPod, for example, and doing play or pause on music, without having to pull out your phone or reach up or do anything. It's just part of your organic use case. And then in the future after that, it's sending, messages or texting or communicating in more complicated ways with others, just using a hearable device. And the reason I can say that is because for a lot of these, we actually have either fully built systems that do some of this work or prototypes. And we're talking to a lot of the best companies in the world that make these types of technology. And, it's pilots are happening, work is happening, and that's really the next step in these types of devices.
Are you talking about even like mind-to-mind communication there in some sense?
It's a little bit more complicated, at least on our demos. It's a little bit more nuanced than that is what I would say. But essentially, being able to put on a pair of Apple AirPods. And right now, for example, I was talking to one of the largest voice companies in the world a couple of days ago. And I asked them, what is your biggest pain point? And they actually gave me 2 pain points. And pain point number 1 is that you can't send a private message, right? Imagine, you're using Alexa or Siri or whoever you want, and you want to send somebody a loved one a message while you're on a bus or a subway, right? It's not going to happen because everyone's going to hear you. And then 2, all that noise is going to create false positives, right? So that was their second pain, false positives from noise. And hearable technology, BCI technology, has the ability to allow us to at least send very simple messages or control our technology in a voice-free kind of way. And instead of having a microphone that picks up sound, it's biometrics that you collect. So it's essentially your own personal microphone. It only works for you. And then that also solves a lot of the privacy issues for voice, because voice, you always have to be listening, right? With this kind of device, you can either just take it off or it only activates whenever you want it to activate, right? And so it solves a lot of these kind of issues that voice has right now in a very simple way.
That's awesome. And then what about the even further future? Like if you had to just kind of go out on a limb and think about even 50, 100 years in the future, what could be possible? Do you have any speculation or big dreams like that?
Yeah, definitely. I mean, at that point, what's really key is that our technology was first originally used actually invasively, the signal processing system that we developed. And so as these invasive companies, let's say 100 plus years from now, start to maybe be used outside of special use case conditions, and you can think of their work as similar to like prosthetics. Right now, it's primarily used for people who, lost a limb. But in the future, who knows, maybe we'll make robotic arms and legs that are better than our own. And so in that case, it might be used for augmentation. So when brain-computer interfaces that are invasive are used for augmentation in the far, far future, this might even be more than 100 years from now. I mean, prosthetics have been around forever, and they're still not, used as an augmentation device for the most part. When brain-computer interfaces are finally at that point, I could see us leveraging our technology to allow them to do even more, right? To allow them to help cure diseases, to allow them to help better understand people, to control devices at a higher fidelity. Essentially, that's what we're doing right now, non-invasively. And so I see the same type of application being done invasively.
And so I know there's some big players like Facebook and Elon Musk's Neuralink that you mentioned earlier that are also working on BCIs. I was reading that Musk's Neuralink can now allow a monkey to play video games with its mind. And so I'm just curious, like just generally speaking, how are you competing with those companies, or what do you think you're doing uniquely at Neurable?
Yeah, I think we're really well positioned at Neurable, especially because we don't necessarily see groups like Neuralink or others as competition. They're invasive. Like for example, Nike doesn't compete with a prosthetics company, right? Like they're very different types of systems, right? One of them is buying a pair of shoes. The other one is getting a prosthetic limb, in their scale, their use case, etc. What I would say is more closely related to like non-invasive brain-computer interfaces. How do we position ourselves to them? At least on the consumer end, most of consumer products that are brain-computer interfaces just don't work. And the reason for that is because it's very hard to collect reliable signal from the brain. And that's something that our team has had significant expertise in. We developed our tech in a laboratory setting. We have really strong, deep core IP that enables us to do that. And that's why we can do the demos that we've done. And what's really interesting is, I've seen some companies do demos similar to like our 2017 system, where they were able to use their brain to like click on an object on a computer screen. And I think it's crazy to think that like that's where the world is now, right? We were there 2016. Actually, we had that demo ready in 2015, right? And so it just shows you how far ahead we are compared to anything else in the market. And that's where I think that's what's really exciting to me, because they're starting to see the things that we saw in 2015, and now it's 2021. So, it's like we're a little bit into the future compared to where everybody is.
And I imagine you've got some patents and there's probably some stuff you're not even allowed to talk about that you figured out that other companies maybe haven't figured out yet.
Exactly. Yeah. There's a lot of pitfalls, a lot of other issues. There's a lot of tech that we've, and actually some companies reach out to us to see if they can license our IP, because they're finally starting to hit those time points and they're like, oh crap, somebody already figured this out, right? Like we tend to be an incredibly open company. So we work with as many partners as we can. Like we're not here to slow down the world. We want the world to speed up. Our goal is to try to stay on top as best as we can. And we definitely have some of the best and brightest people doing that.
Do you think there is a future where most people are getting a surgical implant on their brain at some point? The way that Elon Musk talks about adding this layer to our cortex and that type of thing?
Yeah, I think there definitely is a future. It's just much farther away than Elon Musk suggests, in my personal opinion. And once again, the best example of that is look at these devices that we have that are medical devices that exist now. And I think a great analogy is like, for example, prosthetic limb. It's like we don't, there's so many roadblocks and challenges to make them even better than an augmenting system. And if you're going to risk your life to get a surgical implant, it has to give you a benefit that's significant, even if it lets you like, I don't know, solve math problems a little bit faster in your head. Guess what? We have computers for that, right? Like people don't trade with as much now, like themselves. They mainly do it algorithmically. At least, a lot of the biggest companies in the world are doing that. And normal standalone computers are going to be able to solve a lot of those problems. It's going to be much, much later in the product's evolution where it's going to make sense for you to risk your life to get an implant put inside you. Like, I'm a big fan of BCIs, and even I'm hesitant about it. You know what I'm saying? So, so
Yeah, I don't want anyone going near my brain until a few others have gone before, at least.
exactly.
But yeah, I guess my biggest personal concern is that it becomes too much of a crutch. Like, I'm thinking of a scenario where, if we're relying on a machine to tell us when we're tired, when the brain's already sending those signals to us, and we just have to learn to be more aware and more in touch with our minds, it could get to a point where we're kind of mindless and overly reliant on machines to direct our lives. I don't know if you have any thoughts on that, because that's just one concern that came up for me, is like, if we're replacing metacognition, if we're relying on a machine, it's definitely useful if you're driving a car. You don't want to rely on your own faulty software to detect the car in the lane next to you all 100% of the time. But in the case of your everyday life, if you're replacing metacognition or some of those other psychological skills that you can train, then it seems like in some sense it could make us less aware and less in touch with just life as a human in some sense.
That's a really great comment to bring up. And this reminds me of actually David Eagleman. He's one of our advisors. His latest book, Livewired, and he talks a lot about this. And I also worked in a lab with Dr. Dan Ferris, where we worked with people and basically give them like fake muscles, so that we could augment their capability to see how their brain changes based off of this. And what I thought was really interesting from the book, and I've talked to Dr. Eagleman about this before too, which is, the key thing is that your brain actually uses it as a learning device, right? So for example, if we are able to tell you when you're fatigued 30 minutes before an accident happens, and we do that continuously, instead of you becoming overly reliant on it, your brain actually learns to identify that moment more easily. And so what you can actually do is you can remove the headphones or the device from the person, and then in the future, they're able to do it by themselves. Because what we're actually doing is we're making the body learn that trigger point more easily, because we're allowing that some sort of feedback when that activation happens. In the case of Livewired, they had an individual, for example, put on a vest that had motors that vibrated, and they essentially helped the person understand, I think it was like how to navigate through an environment or something like that. And then when they took the vest off, they had better spatial awareness just in general, right? As if they were wearing it, but it was already off. And that's because other parts of the brain also essentially got that feedback and were able to better fire together to reproduce the effect of the vest even when it wasn't there. And so, yes, there can be some sort of dependency that happens sometime in the future in other applications. But for the most part, I believe that what's going to happen is that our brain is going to use it as a way of creating feedback and learning, and make people be able to take control of it in their hands more often.
Yeah, it's a really good point, because I think about that in the context of Enten and focus. And I can imagine, if you suddenly wake up out of your daydream or your clickbait sinkhole 30 minutes later and you go, oh, darn, I should have been on task. You've learned the lesson way too late. And if you are getting that signal right away, you might learn to detect, oh, okay, yeah, I shouldn't have, switched windows, or I shouldn't have responded to that text earlier. If you're getting that feedback loop early, the negative or positive reinforcement that you're getting, you could just learn more lessons.
For sure. And at least it might make you conscious of those lessons, right? Like, for example, it goes from you switching windows and going off task and not noticing it, to even when you don't have a device on that helps you monitor that, you switch the windows and your brain says, wait a minute, like, this looks familiar. This looks like one of those times where I'm about to, lose the next 2 hours in this internet sinkhole. And then from there, at least you can make a conscious decision because you're aware of it, right? And And I think a good example of that is sometimes, I'll be communicating with somebody and they'll say like, oh, you really hurt my feelings when you said XYZ. And like in my head, I didn't mean it in a bad way at all, or, it was just some feedback. But now I'm aware in the future that if I provide this feedback or if I say it this way, it has a potential to be miscommunicated. And if I didn't get that feedback, then I would never be able to identify it, right? And so it basically allows you to create identification loops for the way you use your technology.
Yeah, that's really interesting. So it can, in some sense, enhance your awareness that wasn't there before and actually build more awareness because you're getting a signal that just wouldn't have been there without it.
Exactly. And then in the future, you're going to be able to better identify those moments yourself.
So are you ready for the rapid fire section of the interview?
Sounds good.
Okay, buckle up. So disregarding any possibility of it actually happening, getting as wild as you want with it, what's one thing you choose to control in your mind or with your mind, if you could?
Yeah, I think that the thing that I would decide to control, what do you mean? Not to allow another device to control it, but to have it in my mind?
What's something that, let's say that mind control is really just taken to the extreme. What's something that you'd like to be able to control with your mind?
Gotcha. I think that what that is, it's going to be a bigger concept than you might want, but I believe that the future of everything is ahead of us. The ability to put on an earbud, and instead of going to the front desk to check in at a hotel, you just walk up to your room. It already knows which room you need, what floor you need to go to. When you walk into the elevator, the door is unlocked when you get there because it knows you're around the corner. Like, it creates just this seamless interface for you in your life. So, imagine a world without friction, right? That's to me is like what I want to accomplish.
That's awesome. What's the most daring thing that you've ever done?
I would say probably starting a startup company. It's crazy. It's, there's so many ups and downs. There's so many roller coasters. I learned through this process that I am a betting man, and, I'm betting on the future. And so this is definitely the craziest thing I've ever done.
Yep. It's a brave thing. You're putting yourself out there, and, one thing, like we were talking before this, there's not that many brain machine or brain computer interface consumer companies at this point, right? So it's you guys are kind of a rare bird.
Yeah. And that's what makes it even scarier, right? Because VCs, as much as they say, like, I've talked to a ton of them, they're like, oh yeah, we're the type of VC that when everyone goes right, we go left. What the truth is, they're all bandwagoners, right? Like, when everybody goes right, they want to go right, and so they like to see patterns. They like to do what they know. And because of that, having something that's a little bit farther out there not only represents a bigger opportunity for them, but it also means that it's harder to find those people who really understand the types of opportunities that change the world.
What would you like to be remembered for?
I would say I believe that what the legacy I want to leave behind is that Neurable was able to create the everyday brain-computer interface, the device that is so seamless to put on, that fits and works beautifully with people, that it starts to generate, a revolution essentially. Think about the iPhone. I think it's like 12 years old now, right? And Uber came out. Uber wasn't successful until the iPhone, essentially allowing GPS in your pocket everywhere. Industries were created because of the iPhone. The world completely transformed to having data in your pocket. And I think brain-computer interfaces have the potential to do that. And that's really what we at Neurable are accomplishing and working on creating.
And then finally, you have a 15-second commercial that goes out to the world. What message would you want to share for people to improve their lives?
What I would say is that technology has been changing dramatically. Unfortunately, a lot of technology is done for technology's sake. It's like They're building a better mousetrap, or they're building a mousetrap to build a mousetrap, essentially, with lasers. And like, I've seen water bottles with like smart sensors in it. It's like, we don't necessarily need to put technology in everything. We believe in human technology. It's not about smaller bezels or bigger screens, but like, how do you truly make something that connects with people, that gives them value, that makes them be the best version of themselves in a way that makes them feel accomplished, that makes them feel rewarded? How do we allow people to communicate in a seamless way? And that's really the value of what Neurable is working on, and the type of technology and the differences that we're able to bring.
Cool. Yeah. I mean, well, it's really exciting to hear about where all this is headed, and I'm looking forward to trying out some of these tools. I mean, it really is an exciting time. And yeah, where can folks either can they purchase it yet? I can't recall whether it's on sale yet. The Enten.
We had a small little sale window that we did in order to get about 1,000 people to help us out with developing the tech. Really, because our company is a deep tech company, we were focusing on licensing the technology to some of the biggest players in the world. Imagine a future where you just go pick up a Bose headphone or an Apple AirPod, and it has our technology inside of it. So you can't get them right now, but if you want to be in touch with us, we have a Discord server with over 2,500 people who all love neurotech, who help us by coming in and doing data collections, testing out our prototypes, chatting with us. I'm on there, providing us feedback, etc. So that's the best way to do it. We're also on Twitter, on Facebook, etc.
Okay, great. So that's the best way for people to stay updated on your work.
Absolutely.
Follow Neurable. Awesome. Well, listen, Ramses, this has been a lot of fun, and thanks for taking the time to come on the FitMind podcast.
My pleasure. And thank you so much for the opportunity.